Good afternoon, Chairperson and everybody. So I will be presenting about coastal vegetation and their functions in reducing tsunami damage. So my topic is a little bit related to engineering, even though I am in this group. First, the content of the presentation include introduction, objective of the study, materials and methods, results and discussion will be discussed under 3 categories, and finally conclusions. So first we will talk about what is tsunami. So all we have experienced tsunami in 2004, December in Indian Ocean. So due to that tsunami, there was severe damage, especially the countries located in Indian Ocean. And in Sri Lanka also, we suffer about 2/3 of Sri Lanka. Okay, especially western, southern, and eastern coastline were severely damaged because of this tsunami. That is the first time we experience that type of damage in a huge scale. Therefore, after that we experience some small amount of, severity is not much previous one. So if we consider if we show some photographs, so these are some of the photographs obtained in 2004 tsunami December. This photo is taken at Phuket, Thailand, and here also you can see tsunamis attacking to the ground. Here the damages that caused due to tsunami you can find. Then you can imagine the amount of energy associated with tsunami. So it can create lot of damages to the infrastructure, people, and other coastal vegetation and other coastal properties. So this is another example. And very recently we experienced another tsunami in Japan in 2011 last year. And in that time, Japanese people also experienced severe damages. These are some of the remainings after the tsunami. So you can find here earlier there was a village here, but that entire village was washed out due to tsunami, and now we can see some a few buildings are remaining. So you can imagine the severity of the tsunami, and you can see here some coastal structures have been destroyed because of the tsunami. And here you can see there's a ship. This ship has moved about 1 kilometer from the shoreline because of the tsunami. And this is another famous photo. This is very popular in the world. This is also from the Japanese tsunami in 2011. So these damages give some emphasis to develop some methodologies to minimize or reduce the severity of tsunami in future. And many researchers and institutions, they are developing some methodologies to minimize or reduce the severity of the tsunami damage, because in future we cannot expect whether we will get tsunami or not, but we have to establish some protective measures at the coastal areas, especially in Indian Ocean and the countries very close to Japan. When we consider previous research in 1983, these people found that experimentally when tsunami is passing through obstacle, okay, energy associated with the tsunami is dissipated. So they found that if we can put some obstacle at the coastal areas, we can reduce the energy of tsunami up to some extent. So when we consider the obstacles, we can see coastal forest, wave dissipating blocks, rock breakwaters, sea walls, etc. So if we can establish one of the obstacle at the coastal areas, we can reduce the energy associated with the tsunami up to some extent. So when we consider these obstacles, here you can find coastal forest. They are very natural, and there are some man-made structures, especially wave dissipating blocks, rock breakwaters, and sea walls. So if you are going to establish these man-made structures, they will give some adverse effect to the coastal environment and ecosystem. Therefore we have to consider that factor also. In addition, we have to consider the cost. So if we are going to establish these artificial structures at the coastal area, we have to spend a lot of capital and also maintenance cost. So especially countries like Sri Lanka, we cannot bear that type of capital and maintenance cost. Therefore, we have to look at low cost and also environmental friendly method to establish the coastal areas to protect from a future tsunami event. So these pictures show some example for the obstacles at the coastal areas. This one, coastal forest. This photo I took from the eastern coastline of Sri Lanka. This is a sea wall located in Japan. This is also wave dissipating blocks. When we consider these two structures, you can see if you are going to construct sea wall at the beach, so you can see it cover the whole beach front, and so the aesthetic value of the beach front will be lost. Another thing is we cannot bear the capital cost associated with this sea wall. Similarly, you can see if you are going to put some wave dissipating blocks to protect from tsunami, so you can see it is aesthetically not very attractive. Therefore, we have to go for alternative solutions. So as an alternative, we can introduce coastal vegetation. There are some other benefits also from the coastal vegetation. So other thing is countries like Sri Lanka, as I mentioned earlier, we cannot go for this type of structures because these are very they take a very high capital cost and also maintenance cost. As an alternative, we can go for coastal forest. When we talk about coastal forest, they provide a range of protection options against tsunami, and also they are economically countries like Sri Lanka, we can apply these things because it is low cost method. And also when we install coastal vegetation in the beach side, it gives some aesthetic appearance. Okay, so that is also another additional advantage. Therefore, we can implement coastal forest at the coastal areas to protect from a future tsunami event. So if we consider the method that reduce the energy associated with the tsunami is, when the tsunami is passing through the coastal forest, the energy or the severity of the tsunami waves are significantly reduced because of the drag characteristics of coastal forest. When the tsunami hits on the coastal forest, the energy associated with the tsunami is reduced because there are some drag characteristics of the coastal forest. Therefore, the objective of the present study were to identify the different types of vegetation species that help to mitigate the tsunami damage, and second one, to analyze the drag characteristics of different vegetation species. So in order to achieve that objectives, we did a field survey at the eastern coastline of Sri Lanka. So altogether there were 30 locations. The survey method was to travel and make the observation on each and every location. So we travel at each and every place and identify what are the possible coastal vegetations that we can establish at the coastal areas. During the field survey, we observed that in some of the areas there are planted casuarina trees. Casuarina means finest trees. They have been planted before and after the Indian Ocean tsunami in 2004. And in some of the locations we found natural vegetations, and in some other locations we found there are no any vegetations. Therefore, it is important to establish coastal vegetation belt at eastern, especially this eastern coastline of Sri Lanka, because this area was severely damaged due to the Indian Ocean tsunami in 2004. So during the field survey, we observed that there are some planted casuarina trees, finest, at the eastern coastline of Sri Lanka. These forests have been planted by different NGOs and government organizations. So, and some of them are planted before the Indian Ocean tsunami in 2004, and some of them have planted after the tsunami in 2004. So you can see here one coastal forest The width of the coastal forest is about 50 meters.